Hello everyone. Today we are going to see two of the more important points in fluid mechanics. Out of that, one is hydraulic turbines and second one is pump. So myself Abhinandan Sangave, and we start this slide by the introduction of what are the hydraulic machines. So basically, machine which convert hydraulic energy, which means energy possessed by water, into mechanical energy are known as turbine. On the other hand, the machine which converts mechanical energy into hydraulic energy are known as pump. Then next one is hydraulic turbines. So hydraulic turbines have a row of blades fitted to the rotating shaft or a rotating plate. Flowing liquid, mostly water, when passed through the hydraulic turbines, it strikes the blades of turbine and makes the shaft rotate. While flowing through the hydraulic turbines, the velocity and the pressure of liquid reduces. These results in development of torque and rotation of the turbine shaft. Apart from this, basically the hydraulic turbines are divided into five classes. Out of that, first is based on the flow path, second one is based on pressure change, third one is based on head, fourth one is based on specific speed, and fifth is based on deposition of turbine main shaft. Now, if we talk about based on flow path, then it is again divided into three categories. Out of that, first one is axial flow hydraulic turbines. In this category of hydraulic turbines, has the flow path of liquid mainly parallel to the axis of rotation. Kaplan turbines has liquid flow mainly in axial direction. Then next two are radial flow hydraulic turbines and mixed flow hydraulic turbines. In radial flow, such hydraulic turbines has the liquid flowing mainly in a plane perpendicular to the axis of rotation. While in mixed flow hydraulic turbines, the most of the hydraulic turbines used, there is a significant component of both axial and radial flow. Such types of hydraulic turbines are called as mixed flow turbines. Francis turbine is an example of such type in that water enters in radial direction and exits in axial direction. Then next one is based on head. So basically it is divided into three types. First one is high head turbine, which is mainly about 250-meter, and the best example of this type is Pelton turbine. Second one is medium head turbine, which mainly varies from 60 to 250-meter, and the Francis turbine is the typical example of this category. And below 60-meter head, they are known as low head turbines, and the Kaplan turbine is the main example of this category. Then based on layout of hydraulic electric power plant, uh, here is the image showing the hydraulic power plant. Here we can see there is a reservoir, intake, dam, generator, transformer, powerhouse. Then turbine is situated in the powerhouse, and from there water is outflow is provided. Then parts of hydroelectric plant. So in that, first one is dam. It raises the water level of the river to create filling water. Also controls the flow of water. The reservoir that is formed is in effect stored energy. Then next one is turbine. The force of falling water pushing against the turbine's blade causes the turbine to spin. A water turbine is much like a windmill, except the energy is provided by falling water instead of wind, and the turbine converts the kinetic energy of falling water into mechanical energy. Then next one is generator. It is connected to the turbine by shaft and possibly gears. So when the turbine spins, it causes the generator to spin also. It also converts the mechanical energy from the turbine into electric energy. And generators in hydropower plants work just like the generators in other types of power plants. Next one is transmission lines. It conducts the electricity from hydropower plant to the homes and businesses. Then Pelton turbine. In that, water strikes the vane along tangent of the runner, and energy available at the inlet of turbine is also kinetic energy. Therefore, it is a tangential flow impulse turbine. In Pelton turbine or Pelton wheel, water jets impact on the blades of the turbine, making the wheel rotate, producing torque and power. Next, Main parts of a Pelton wheel. So nozzle is the one of the main part. It controls the amount of water striking the vane of the runner. Then next one is casing. It is used to prevent splashing of water and plays no part in power generation. Third one is runner with bucket. Runner is a circular disc on the periphery of which a number of evenly spaced buckets are fixed. And next one is braking jet. To stop the runner in short time, braking jet is used. So here is the diagrammatic view of Pelton wheel where we can see a penstock from where water comes, and with the help of spear we can control the velocity of water which is imparted on the buckets which are placed on the periphery of the wheel. Then if we talk about the working principle of Pelton turbine, in that water jets emerging strikes the bucket at the splitter and split into two. Stream flow along the runner curve of the bucket and leave it in the direction opposite to that of incoming jet. The high pressure water can be obtained from any water body suitable at the some height or streams of water flowing down at the hill. The change in momentum of water stream produces an impulse on the blades of the wheel of Pelton turbine. This impulse generates the torque and rotation in the shaft of Pelton turbine. In that, again it is divided into two types. First one is horizontal shaft, where not more than two jets are used, and second one is vertical shaft, which is large number of jets are used. Francis turbine. So it is the first hydraulic turbine with radial inflow. In that water flows from outward to inward, that is inward radial flow turbine. Francis turbine is a reaction turbine as the energy available at the inlet of the turbine is a combination of kinetic and pressure energy. The water pressure decreases as it passes through the turbine imparting reaction on the turbine blades making the turbine rotate. Then main parts of a Francis turbine. First, casing. The runner is completely enclosed in an airtight spiral casing. The casing and the runner are always full of water. Second one is guide mechanism. It consists of stationary circular wheel on which stationary guide vanes are fixed. The guide vanes allow the water to strike the vanes of the runner without shock at. Third one is runner. It is a circular wheel on which a series of curved radial guide vanes are fixed. Next, draft tube. It is used for discharging water from outlet of runner to the tail race. Then, these are typical pictures of Francis turbine, where we can easily see the runner, movable vanes, guide wheels, and stationary guide vanes. If we talk about the working principle of Francis turbine, then they are generally installed with their axis vertical. Water with high head enters the turbine through the spiral casing surrounding the guide vanes. The water loses a part of its pressure in the volute, which is nothing but spiral casing, to maintain its speed. When water passes through guide vanes, where it is directed to strike the blades on the runner at optimum angles. As the water flows through runner, its pressure and angular momentum reduces. This reduction imparts reaction on the runner and power is transferred to the turbine shaft. If the turbine is operating at the design condition, the water leaves the runner in axial direction. Water exits the turbine through draft tube, which act as a diffuser and reduce the exit velocity of the flow to recover maximum energy from the flowing water. Next one is Kaplan turbine. It is an axial flow reaction turbine in which the water flows through runner of turbine in an axial direction and the energy at the inlet of turbine is the sum of kinetic and pressure energy. In an axial flow reaction turbine, the shaft is vertical. Lower end of shaft is a hub or boss. On the hub vanes are attached. If the vanes are adjustable, then it is called as Kaplan turbine, and if vanes are not adjustable, then it is called as propeller turbine. Best suited where the large quantity of low head water is available. Kaplan turbine has propeller-like blades but works just reverse. Instead of displacing the water axially using shaft power, and creating axial thrust. The axial force of water acts on the blades of Kaplan turbine and generating shaft power. Then main parts of Kaplan turbine are scroll casing, guide vane mechanism, hub with vanes, draft tube, and this is the typical picture of the Kaplan turbine. If we talk about working principle of Kaplan turbine, the working head of water is low, so large, flow rates are allowed in the Kaplan turbine. The water enters the turbine through guide vanes, which are aligned such as to give the flow a suitable degree of spill determined according to the rotor of the turbine. The flow from guide vanes pass through the curved up passage, which forces the radial flow to axial direction with the initial swirl imparted by the inlet guide vanes, which is now in the form of free water. The axial flow from water with components of SVERI applies force on the blades of the rotor and loses its momentum, both linear and angular, producing torque and rotation in shaft. The scheme for production of hydroelectricity by Kaplan turbine is same as that of Francis turbine. This is the comparison where Pelton turbine, Kaplan turbine and Francis turbine are compared. So first, if we talk about the type of turbine, then Pelton turbine is an impulse type, Kaplan turbine is a propeller type, whereas Francis turbine is an inward flow reaction type. If we talk about power generation in megawatt, the Pelton turbine generates 400 megawatt power, where Kaplan turbine is 200 megawatt, and Francis turbine generates highest power, which is nothing but 800 megawatt. If we talk about speed rate in RPM, then in Pelton turbine it ranges from 65 to 800. In Kaplan turbine it ranges from 70 to 429, and in Francis turbine it ranges between 75 to 1000 RPM. And if we talk about the efficiency, the Kaplan turbine has the lowest efficiency, which is 80, and whereas the Francis turbine has maximum efficiency, which is equal to 90%. Then next component is draft tube. So it is a pipe of gradually increasing area which connects the outlet of runner with the tail race. One end of the draft tube is connected to the outlet of the runner, while the other end is submerged below the level of water in the tail race. It creates a negative head at the outlet of the runner, thereby increasing the net head on the turbine. It converts a large portion of rejected kinetic energy into useful pressure energy. Governing of turbines. It is the operation by which the speed of turbine is kept constant under all the conditions of working load. This is done automatically by a governor which regulates the rate flow through the turbine according to the changing load condition on the turbine. It is absolutely necessary if the turbine is coupled to an electric generator which is required to run at constant speed under all fluctuating load conditions. Now the next one is pumps. The pump is a mechanical device which conveys liquid from one place to another place. It can be defined as hydraulic machine which converts the mechanical energy into hydraulic energy. The pump is power absorbing machines. The power can be supplied to the pump by a prime motor like an electric motor, an internal combustion engine or a turbine. Pumping means addition of energy to a liquid to move it from one place to another, and this done by means of piston, plunger, impeller, propeller, gears or screw depending upon the type of pumps. If we talk about application of pumps, the pumps are used for various applications in various fields such as thermal engineering, which is in that it is used to feed water into the boiler, to circulate the water in condenser, and to circulate lubricating oil in the propeller place in various machines. It is also used in agricultural and irrigation purpose to lift water from deep well and to convey water from one place to another. Then it is also used in chemical industries, in municipal water works and drainage system, and in hydraulic control systems. Classification of pumps. The pumps can be classified according to principle by which the energy added to the fluid and their design features as follows. First, positive displacement pump. These pumps operate on the principle of definite quantity of liquid is discharged or displaced due to the positive or real displacement of working element like piston, plunger, gears, etc. In that, first one is reciprocating pump. So again, it is divided into three types. One is piston pump, second one is plunger pumps, third is bucket pump or hand pumps. The piston pump is again divided into two types: single cylinder, single acting or double acting, and double cylinder, single acting or double acting. And second, it is rotary pumps, and it is again divided into three types. One is gear pumps, second one is vane or lobe pumps, and third one is screw pumps. In second category, it is known as rotodynamic pump. These pumps operate on the principle of the rise in pressure energy of liquid by dynamic action of liquid. The dynamic action of liquid is carried by a revolving wheel which has curved vanes on it. This wheel is known as impeller. In that, first one is radial flow pump. In this pump, addition of energy to the liquid occurs in the flow of liquid in radial path. In that, first one is centrifugal pumps, which may be single stage or multi-stage. Then second one is axial flow pump, and third one is mixed flow pump. In axial flow pump, the addition of energy to liquid occurs when the flow of liquid in axial direction, whereas in mixed flow pump, the addition of energy to the liquid occurs when the flow of liquid in axial as well as in radial direction. And the third category is other type of pumps. In this type of pump does not belong to the category of positive displacement or rotodynamic type pump as follows: jet pump or air lift pump. Then next one is centrifugal pump. If the mechanical energy is converted into pressure energy or kinetic energy by means of centrifugal force acting on the fluid, the hydraulic machine is called centrifugal pump. These are main parts of centrifugal pumps, which mainly include overhead tank, then delivery pipe, delivery valve, delivery flange, then casing, impeller, pressure gauges, vacuum gauge, suction flange, suction pipe, sump, put valve, and strainer. Then main parts of centrifugal pumps are listed below. Out of that, first one is casing. It is an airtight passage surrounding the impeller, and it's designed in such a way that the kinetic energy of liquid coming from impeller is converted into pressure energy before delivery pipe. There are basically three types of casing. One is volute casing, second one is vortex chamber casing, and third one is volute casing with guide blades. Next one is impeller. It is a rotating element of a centrifugal pump. It consists of finite number of backward curved vanes. The number of vanes normally 6 to 12 in the impeller. Impeller is mounted on shaft which is coupled with the shaft of electric motor. In impeller, the kinetic energy of liquid is increased. The different types of impeller for different types of flow shown below. First one is axial flow, second one is radial flow, and third one is mixed flow. Then types of impeller. So basically there are three main categories of impeller which are used in the centrifugal pumps. First one is radial vane, which is shown in figure A. Second one is backward vane, which is shown in figure B. And third one is forward vane, which is shown in figure C. Now there are different types of heads of pump available, which we are going to see in next 2 to 3 slides. Out of that, first one is static suction head. So it is the vertical distance in feet or meter from the center line of the pump to the free level of the liquid to be pumped. Second one is static discharge head. It is the vertical distance between the pump center line and the point of free discharge or the surface of liquid in the discharge tank. Third one is total static head. It is the vertical distance between the free level of source of supply and the point of free discharge or the free surface of the discharge liquid. Then next one is friction head, which is denoted by HF. It is the head required to overcome the resistance to the flow in the pipe and fittings. Then second one is velocity head, which is denoted by HV. And it is the energy of a liquid as a result of its motion at some velocity v. It is the equivalent head in feet through which the water would have to fall to acquire the same velocity. And last one is manometric head. It is the sum of actual lift, that is static head, plus frictional losses in the pipe plus discharge velocity head. If we talk about the working of this, then the suction valve of the pump to be opened up, which cause fluid flow to the impeller and fill the volute of the centrifugal pump. Open the vent valve, which is on discharge line before the discharge valve of centrifugal pump, which cause all air to move out of the casing and filled with the pumping fluid only. When some quantity of the fluid comes out from the vent valve, close the valve. Now open the bypass valve of the discharge valve, which is near or side of the discharge valve on the discharge line. Now start the pump and let it attain its capacity in the pressure gauge on the discharge line. When the pressure gauge is stable, it is time to open the discharge valve of the centrifugal pump. Next one is priming. It is the operation in which the suction pipe, casing of the pump and the portion of the delivery pipe to deliver valve are completely filled with the liquid which is to be pumped. It has been observed that even the presence of all small air packet in any of the portion of pump may result in no delivery of liquid from the pump. The necessary priming of centrifugal pump is due to the fact that pressure generated in centrifugal pump impeller is directly proportional to the density of the fluid that is in contact with it. If the impeller is made to rotate in the presence of air, only negligible pressure would be produced with the result that no liquid will be lifted up by the pump. Next, reciprocating pump. These pumps are used to increase the energy level of water by virtue of which it can be raised to a higher level. Reciprocating pumps positive displacement pump, that is initially a small quantity of liquid is taken into a chamber and is physically displaced and forced out with pressure by moving mechanical element. The use of reciprocating pumps is being limited these days and being replaced by centrifugal pumps. For industrial purpose, they have become obsolete due to their high initial and maintenance cost as compared to the centrifugal pumps. Small hand-operated pumps are still in use that include well pumps. These are also useful where high heads are required with small discharge as oil drilling operations. These are main components of reciprocating pump, which mainly involve delivery pipe, delivery valve, piston, cylinder, piston rod, suction valve, and suction pipe. A reciprocating pump consists of a plunger or a piston that moves forward and backward inside a cylindrical cylinder with the help of connecting rod and a crank. The crank is rotated by an external source of power. The cylinder is connected to the sump by a suction pipe and the delivery tank by a delivery pipe. At the cylinder end of these pipes, non-return valve are provided. The non-return valve allows the liquid to pass in only one direction. Through suction valve, liquid can only be admitted into the cylinder, and through the delivery valve, liquid can only be discharged into the delivery pipe. When the piston moves from left to right, suction pressure is produced in the cylinder. If the pump is started for the first time or after a long period, air from the suction pipe is sucked during the suction stroke, while the delivery valve is closed. Liquid rises into the suction pipe by a small height due to atmospheric pressure on the some liquid. During the delivery stroke, air in the cylinder is pushed out into the delivery pipe by the thrust of the piston while the suction valve is closed. When all the air from the suction pipe has been exhausted, the liquid from the sump is able to rise and enter the cylinder. During the delivery stroke, it is displaced into the delivery pipe. Thus, the liquid is delivered into the delivery tank intermittently, that is, during the delivery stroke only. This is the image showing the reciprocating pump which mainly involve delivery pipe, suction pipe, piston rod, and sump. This is the comparison between centrifugal pumps and reciprocating pump. In centrifugal pump, the flow is steady and even, whereas in reciprocating pump, it is intermittent and pulsating. In centrifugal pump, for used for large discharges and small head, whereas reciprocating pump is used for small discharge and high heads. Centrifugal pumps can be used for viscous fluids, that is oils, muddy water, and reciprocating pump can be handle pure water or less viscous liquid only. Otherwise, will gauge frequent trouble. In the centrifugal pumps are having low initial cost, whereas reciprocating pump has high initial cost. Centrifugal pump can run at high speed, can be coupled directly to the electric motor, whereas reciprocating pumps are low speed and belt driven arrangement is necessary. The centrifugal pumps having low maintenance cost, periodic checkup sufficient, whereas the reciprocating pumps has high maintenance cost and frequent replacement of parts involved. In centrifugal pump, compact less flow required, whereas in reciprocating pump needs 6 to 7 times area than the centrifugal pumps. In centrifugal pumps, low head pumps have high efficiency, whereas the efficiency of low head pumps as low as 40% due to energy losses. In centrifugal pumps, it required uniform torque, whereas in the reciprocating pump, torque is not uniform. Then in centrifugal pump is simple construction, less number of spare parts needed, whereas reciprocating pump is complicated construction, more number of spare parts are needed. Then submersible pump. It is an main indicates consist of electric motor and pump both. By submerging electric motor or pump, large economy can be achieved. The only problem is of motor winding and other electric connections. For this, special arrangement is done for prevention dangers. These pumps are vertical centrifugal pumps with radial or mixed flow. All metallic bearings are water lubricated and protected against the sand. Then selection of pump. Basically, it depends on five important factors. Out of that, first one is the quantity of liquid to be handled. This primarily affects the size of the pump and determines whether it is desirable to use a number of pumps in parallel. Second one is the head against which the liquid is to be pumped. This will be determined by the difference in the pressure, the vertical height of downstream and upstream reservoirs, and by the friction losses which occurs in the delivery line. The suitability of centrifugal pump and the number of stages required will largely be determined by this factor. Third one is the nature of liquid to be pumped. In that, for a given throughput, the viscosity largely determines the frictional losses and hence the power required. The corrosive nature will determine the material of construction both for the pump and the packing. With suspensions, the clearance in the pump must be large compared with the size of the particle. Fourth factor is the nature of power supply. If the pump is to be driven by an electric motor or internal combustion engine, a high-speed centrifugal or rotary pump will be preferred as it can be coupled directly to the motor. The last one is if the pump is used only intermittently, corrosion troubles are more likely than with continuous working. Thank you.